So here's a stoichiometry problem. I know that it is stoichiometry because I'm talking about the amount of a product and given the amount of a reactant. I also see that it wants to know the maximum amount of carbon dioxide that can be produced. Remember that maximum amount is another word or term for saying theoretical yield. And in order to do this, I'm going to need a balanced chemical equation. So let's start there. My fuel is C2H2. And then this is combustion. So my other reactant is oxygen. And again, complete combustion is what I'm going to assume. That will give me the maximum CO2. So I know CO2 is one product, and I should know the other product is water. Now we can't do stoichiometry until we have correct coefficients, which means we need to balance this. So I'm going to start on combustion. You save oxygen for last. So I'll start with my carbon. I have 2 here, so I'll put a 2 there. Hydrogen, I have 2 here, so I'll put, so I'm good there. And then I will count my oxygens on this side. I have 4. 2 times 2, there's 4 there, only 1 there. So my products, I have 5. Well, that doesn't work too well over here because I can't put a number here to get 5. So this one's a trickier one to balance. So what you do when you end up with this even-odd problem, as I just did, is you go back and double everything you already determined. So I'm going to put a 2 here, doubling the 1. I'm going to just cross through this so you can see. I'm putting a 4 here, and this was a 1, but I'll put a 2. So I can check my carbon, it should still be balanced. 4, 4, hydrogen, 4, 4. Now let's check oxygen. I have 4 times 2, that's 8 there, plus 2 there. That's a total of 10 on this side. And so now I can see I need a 5 here. Okay, so now we have a balanced chemical equation. So now let's get ready for our stoichiometry. I have 5 kilograms of acetylene, and that's our fuel here. So I'm going to just put it here. Notice it's kilograms, not grams. And I'm wanting to know the maximum amount in grams of this product, that the carbon dioxide. So from here at stoichiometry, we're going to start with our reactant we know. And remember, with stoichiometry, you need to put kilograms of what and grams of what and moles of what. You need to put the substance because we're going to have 2 different substances in this problem. So normally I go directly to moles in my first step, because once I get to moles, then I can switch compounds to figure out the stoichiometry to go. But I can't use molar mass to get to moles until I get to grams. So I'm going to do that first. Then I can go from grams to moles of acetylene, so that from the moles I can switch compounds. So I need the molar mass of acetylene. I don't have room there. But molar mass is where I look on the periodic table and add up the atomic weights. And I get 26.0 grams. So this is a molar mass step. Next, I'm going to go from moles of acetylene to moles of the compound that I'm interested in, carbon dioxide. And for this step, I use my coefficients. And so this is where I use the coefficients I had up here. The coefficients are the numbers in front. And so this is the coefficient for acetylene and the coefficient for carbon dioxide. I don't want moles. I'm doing a good job of canceling here. Moles. I don't want moles of CO2 though. I want grams of CO2. So I can get rid of moles that way. And here I'm using a molar mass again, this time of CO2. And looking on the periodic table and adding up, it's 44. This is what my calculator says. Looks like I just have 2 sig figs because of the given. And so that's how much carbon dioxide I could get. Let's look at this second question. That's going to require a lot of oxygen for that to happen. What if there was not enough oxygen present, or oxygen wasn't in excess? And so, you know, when we did this, we assumed that oxygen was present in excess. And in other words, it's not a limiting reagent and it has enough to totally oxidize and make carbon dioxide. That's how we get a maximum theoretical yield. But what if oxygen was not in excess? Side. And that's just a good thing to kind of just to know, that if you're burning something and there's not enough oxygen available, some carbon monoxide will form, and of course carbon monoxide is toxic.